Good afternoon, everyone. My name is Xiong. I'm very pleased to have the opportunity to attend the Tribune Census 2019. Today, my topic of the presentation is Reasoning-based metal organic frameworks modified microelectrode for trace mercury detection. By the way, Ru-MOFs will refer to the reasoning-based metal organic framework. My presentation will include these 4 parts. First, background information about this research. Second, the main work we have done. Third, some summary about the research. Last, acknowledgement. Firstly, I will introduce the background of the research. I will begin from the importance of mercury detection. First, mercury is widely used in our living environment. For example, the monitor, pesticide, and preservative, and mercury has a high bioaccumulation factor up to 1 million in the food chain, and its high toxicity can cause serious harm to human health. Therefore, it is very important to monitor the mercury in nature waters. Next, I will introduce some methods of mercury detection. The method of mercury detection mainly includes these 4 solutions: cold vapor fluorescence spectrometry, 2. Cold vapor atomic absorption spectrometry, 3. Inductively coupled plasma mass spectrometry, and electrochemistry. The first 3 methods of this require large, expensive instrumentation and complex operation, so these methods are not suitable for on-site rapid detection. However, the electrochemistry has the advantage of simplicity, low cost, and short time, and it has the potential for rapid detection of mercury in the field, so we choose the electrochemistry to detect. Then, we will talk about how to detect mercury by electrochemistry. Among electrochemistry methods, different pulse stream voltammetry (DPSV) is widely used for mercury detection because it is convenient and has the advantage of high sensitivity. As shown in the left image, this method mainly contains 2 progresses. First, when the working electrode holds low potential for some time, the bivalent mercury will be reduced to 0-valent mercury on the surface of working electrode. Then, when the potential of working electrode increases, the 0-valent mercury will be oxidized to bivalent mercury on excitation potential, so there will be an excitation current peak, and if the concentration of mercury is increasing, the current peak will increase. So, we can detect the mercury by the method. To sum up, electrochemistry method has the advantage of simplicity, low cost, and short time compared with other electrochemical methods. But its sensitivity cannot meet the demand of trace mercury. Therefore, there needs to find a way to improve the sensitivity. How to improve the sensitivity? Some methods have been studied to improve the sensitivity. First, they can use the specificity band between examine DNA and mercury to achieve the detection. This method has a good specific but poor stability. Secondly, they can detect mercury by rhodamine or other small molecular structure with amine or sulfur group. This method has good stability but poor specificity. Enrichment can ensure the stability and has good specificity, so it can solve the problem above. However, the method usually requires in the research, we used a new class of porous metal MOFs to absorb the mercury because of its excellent absorption. And the MOFs is modified on the electrode. It can efficiently improve the electrochemical activity of electrode because MOFs have the advantage of high specific surface area. At the moment, when we detect the mercury ion by electrochemistry, the mercury will be absorbed by MOFs, so we can improve the sensitivity and not require separation by the method. In the recent research, MOFs have been used to detect other metal ions. For example, BZMS-based metal organic frameworks can selectively capture toxic selenium oxide ions, and MOFs can be used for ultra-sensitivity detection of trace arsenic. And MOFs can be used for detection of multiple ions. The indicate MOFs has excellent ability to absorb heavy metal ions, so MOFs-based electrochemical sensor may be solution for on-site rapid detection of trace mercury. Then we will introduce research content. Firstly, we fabricate the gold microelectrode by MEMS technology. The fabrication process involves lithography on the glass substrate, followed by spattering and stripping to obtain the pattern of gold microelectrode. For example, as shown in the left image, this is clean glass. First, spin coating of photoresist, followed by lithography, developing spattering of the gold and stripping of the rest of photoresist. We will get a glass with the pattern of the gold electrodes. As shown in the right image, the volume of electrode is very small. Next, Ru-MOFs forms were prepared by cathodic method. The working electrode is cathode. It means the working electrode holds on negative 1.3 volt for 15 minutes. A large amount of leucine ions get together on the surface due to they are attracted by electric potential. The leucine ions and the deprotonated linkers trigger self-assembly. It will lead to the information of MOFs on the electrode. The SEM images of Ru-MOFs were shown in message. So how about the electrochemistry performance of Ru-MOFs? The electrochemical activity of MOFs was checked in 0.1 mol per liter loosening cyanoate by cynic voltammetry. As shown in message, the black curve refers to bare gold microelectrode, and the Ru-MOFs art AU refers to gold microelectrode with Ru-MOFs. The current response of Ru-MOFs electrode was larger than gold electrode, which indicated that Ru-MOFs on the surface of gold electrode significantly improve electrochemical activity of the electrode surface. 10 dpsv was used for the current response test of sensor to different concentration of mercury. The response curve is shown in the message. As the increasing of mercury, the oxidation current increased. The result indicates that Ru-MOFs modified microelectrode can be used for detection of trace mercury ions in aqueous solution. The linear curve is shown in message. The linear response range from 0.1 ppb to 5 ppb with a correlation coefficient of 0.996. The LOD is 0.08 ppb and the sensitivity is very good. This small size sensor can detect trace mercury rapidly, as the vortex is able to finish within only 6 minutes. So it is suitable for rapid and on-site detection. To sum up, firstly, with fabrication microelectrode by MEMS technology. Then, Ru-MOFs were synthesized by cathodic method, and the sensor shows a good performance of mercury detection. Next, about acknowledgement. This work was supported by research funding from the major state-based research development program of China. That's all. Thanks for listening.